I'm Arvind Naitrikashyap. I'm co-founder and CTO of Rubrik. And today I'll be presenting a technical deep dive into the Rubrik platform. So this is what we see the data center to look like when you have Rubrik in the system. You have a scale-out backup software and dedupe storage all converged into one single stack. And you have replication, long-term retention through a scale-out archive solution that you might use. So what does the Rubrik appliance look like? Very simply, we call it a brick. It's a 2U appliance. Each brick has 4 hardware nodes, and they form a cluster. Each node itself has 3 hard disks and one SSD. But this is just commodity hardware. The intelligence really lies in the software, where it's a completely distributed architecture. There's no single master. So if you lose a node or even a whole brick, the system will continue to operate as before. We can scale incrementally. So as your data needs grow, just keep adding more and more bricks, and it scales out, but still presents a single system to you and leverages all the resources in the cluster to achieve the policies that you've defined. It's a completely shared nothing architecture, and there's no single point of failure.
Nitro, just real quick, can I?
Sure.
Oh, maybe you're going to explain it on that slide, actually.
Yeah.
I was just curious. The brick is the 2U appliance, and then inside of that there are 4 nodes. But you're gonna.
Yeah, I was just going to go into that.
Right.
So this is what a brick looks like, right? So it's actually 4 nodes. They're identical, and then each one has its own CPU, hard disk, SSD, and network connection, and you just connect them to the top of the rack switch. And these so a single brick will form a 4-node cluster. If you add a second brick, then essentially you get an 8-node cluster, 12-node cluster. You just keep scaling it out. And this is just commodity hardware, so it's just an industry standard of a 2U 4-node chassis that we use for this.
Each single node, 2 CPUs.
Each single node is 2 CPUs, and
A lot of power to do the cap.
So we use that for since we run the backup software inside this node, we do the deduplication, the compression, and all of that right in there. But essentially there's nothing special about this hardware. And it's a completely distributed masterless architecture that we use to scale this out into a single cluster. So
what if I have a customer that really wants other hardware?
So again, as I said, it's all the intelligence lies in the software. In the future, we will have a version that we could OEM out other hardware. The reason we took this approach is that it's an easy way for customers to consume it today, but there's nothing special about this hardware. Eventually, we could define a set of hardware requirements that our software could run on, but today this is how we consume this.
At some level, we are inspired by iPhone, and if you look at iPhone versus Android, the full integration of iPhone makes it slightly easier for a lot of people to consume it.
Yeah. So I just want to go over the architecture of the software stack. So we have actually built a whole bunch of components ourselves, and I'll go into why we made that decision. So we have actually built our own file system. It's a scale-out file system. We have our own distributed metadata layer, which acts as a kind of the database for all the other components in the software stack. We built our own distributed task scheduler. I'll go into detail about all of these. We have our own cluster management software that manages the health of the nodes, auto heals if there are any problems, and make sure that it detects any kind of failures in the hardware as well and makes appropriate corrective actions. We have built-in security layer. On top of that, we have the policy engine, which actually lets you define the policy and then run everything based off of that. And effectively, we almost treat backup and recovery, all of these as kind of applications on top of this infrastructure, where you define the policy, and then the system kind of figures out how it can meet those requirements and achieve the goals that you've set through the policy. Everything is controlled through an API. We made this decision very early on that it should be completely API driven. Even our user interface actually uses the API to talk to the backend. So anything you can do with the UI today, you can actually do through the REST API, and essentially it's scriptable, and you can use any kind of your own scripts to automate and do self-service applications as well. And other than that, we have a layer that connects to the cloud. In the current versions, we support Amazon S3 as well as other object stores. I'll go into that into detail. And then we integrate external hypervisors and other sources that we might want to back up. So that's kind of the software architecture. So this is,
I'm sorry, does this product assume that you're virtualized? Or will this back up hardware as well?
I'll go into that in more detail. So you bring the Rubrik appliance, you connect it to the network. Bring the system up is a matter of 15 to 30 minutes. You'll have the system up and running. You add your vCenter credentials, and then Rubrik will talk to vCenter, get all the metadata about all the virtualized infrastructure that you have, and bring it into the system. And then all you do is you define your policies, and you drag and drop your VMs into those policy buckets. And that's all you do. And then the system will take care of ensuring that it'll do all the right work to make sure that you can meet those requirements.
So when it pulls in the metadata out of vCenter, is it a replicated copy of that metadata, or is it actually continually reading out of vCenter?
We constantly keep refreshing the metadata. So we'll get the first copy, but then we have in the background we constantly refresh the metadata so that if you bring in a new VM into the infrastructure, we'll detect that within a few minutes, and it'll show up in our dashboard.
So, and you probably get this, but if I initially bring you in, you do an analysis up front and have an idea of the size of the solution that I'll need to get me my RPO and RTO and all that. So it's not like I need to bring something in, figure out 6 months from now or a month from now. I don't have the resources that I started with.
But it doesn't matter. I mean, you can start with any form factor. We bring in one brick, and then you later realize that, and I'll go to some of those details, but you realize that you need more hardware. You bring in a second node a few months down the road, and again, they all form one single seamless system. So you can just grow as you scale.
But what I'm getting at is when I initially bring this solution in.
We actually provide you a tool,
Okay, so
a calculator that actually collects all the data and loads data into this sizing tool.
Okay.
And then it outputs you like how much for the 30-day or 90-day retention, how much appliance you need or how many appliance you need. And you will start from there. And if you want to put more load onto our platform, or if you want to retain data for longer, then obviously stack it up.
And actually, we have reports that also show you the runway that tells you that, okay, you probably will run out of space within 30 days or 60 days.
Predictive.
So that way, it predicts that so that you can take the action to add more hardware as needed.
So what happens if you have an RPO of like 0 time and you drag this VM over to this RPO and it doesn't have sequential or synchronous replication on the back end of its SAN or anything like that? I mean, how do you support something like an RPO of 0?
We don't support RPO of 0.
Oh.
Because we are a backup and recovery platform, not a
you
synchronous
support an RPO of
replication
1.
platform.
So right now, the minimum RPO support is 1 hour. And again, you don't want to be taking backups of your production system in 1 hour. I mean, there is some impact. I mean, what you want is ability to be able to take backups and be able to recover to a reasonable point in time, but you don't want to be hammering a production system with constant backup requests either.
So on the other side, let's say you want to keep the data around for a year and a half or something like that, and over time you run out of space in order to support that RPO. How is that,
So actually, when you define the policy, and you'll see that in the demo, when you define the policy, you can define how long you want. So let's say you take a backup every 6 hours. You can define that I want to keep these 6-hour backups for 3 days, and then I want to keep only dailies for the next week, and then monthly for a year and yearly for so many years. So over time, as the data ages out, you don't want to keep data that granularity, right? So once you define the policy, the system will make sure that it expires anything that doesn't fall within those parameters that you defined.
That is the most important innovation for the policy engine. Policy engine not only gives you sparse policies, where you can say every 4 hours for first 3 days, then every day for a month, but system is taking a snapshot every 4 hours. It automatically collapses those snapshots into daily and does garbage collection.
I mean, the challenge with something like a deduplication or a compression appliance is that, you can get another backup load into this environment and blow away your space because it doesn't deduplicate, or because that's the first full of some, area that you've never seen before. I mean,
But since this is a single system, so we actually are able to deduplicate globally across all the backups that you ever taken in the past.
Yeah,
Right.
I understand, but the first time you see a full backup of some data store, you're not going to be able to deduplicate that at all.
We have notification engine. I mean, look, the law of physics is at the end of it, you have to obey the law of physics. But as soon as we detect a situation that you have defined a policy and something else suddenly came into the platform, or you decided to bring more load than you had originally anticipated, we start to give you notifications and alerts and saying that instead of next 1 year that you said, we can only support next 6 months or next 3 months. So go increase the capacity or take some workload off of it. Or instead of retaining data for 90 days, now you retain data for 30 days and push it to the cloud, things like that.
Okay.
So this whole policy engine in the back end has a very intelligent monitoring and system that continuously monitors that you defined this, can we really fulfill this requirement? And as part of the GUI, we support 1 hour snapshots. That's the finest you can go. But through our APIs, you can go even more granular. But what we have seen in the marketplace today, people are happy taking backup like every 12 hours or every 24 hours.
Yeah.
When they hear 4, they think that is really possible. More frequent than 1 hour is like unheard of.
And in this case, you're using VMware snapshots in order to create the image that you're going to move over?
Yes.
Yeah, we use VADP to take them. So we take the first full, and then we use change block tracking to take incremental.
We have built some neat innovation in the VMware snapshot because, as you know, if you have a large and very busy VM, VMware snapshots doesn't do a good job. So we have built some parallel ingest algorithm on Flash so that you can take those snapshots rapidly without impacting the performance of the primary application.
The key is to keep the VMware snapshot window as short as possible. So we ingest the data very quickly in parallel across, and so you can actually leverage all the nodes in the cluster to ingest the data, and then to free up the production resource, remove the snapshot as quickly as possible, and then we can finalize the backup. But the goal is to kind of get the data in as quickly as possible so that you have minimal impact on the production system.
And it's an application consistent snapshot that's taken?
Yes. Yes. So we have. Maybe I should actually. I can go and
Go with your flow, maybe answer this question.
Yeah, I'll go. I'm going to go into.
It's okay. We can get to it later.
VSS. So very quickly. So then once you've defined the backup, then as I said, we use VADP to ingest the data into our system. So kind of deep diving into the file system. Right? So the file system is actually a complete scale-out file system. We built this from scratch because we needed a file system on one hand that can compress and dedupe the data and store the data as efficiently as possible so that we maximize the storage utilization. But at the same time, we also wanted the ability to take any version of any backup that you have and be able to spin that up very quickly and give access to it. So you have an option to do instant recovery or even create a copy of that very quickly using Rubrik storage. So we wrote our own file system here, which is completely masterless, scales out, doesn't have a single point of failure. As the data is ingested, since it's a single namespace, however large your cluster is, we are able to do global deduplication compression. It actually uses Flash intelligently to ingest the data very quickly, as well as provide very high IOPS when you want to do an instant recovery directly of Rubrik storage. So we are able to support close to 30K IOPS per brick so you can actually run, if your primary fails, you can actually bring up the virtual machine directly off Rubrik storage and provide pretty reasonable performance.
How am I bringing up when you say I can bring up the VM on the Rubrik instance, you mean the storage part? So I still need to have.
You still need a host.
Yep.
But it's a single button. You go to and you'll see that in the demo. You go to the backup and you say recover, and then the system will go and actually you can specify a host, and then if it's a recovery, it'll actually go to the same host, or you can choose a different host, and it'll create a VM using Rubrik as an NFS data store. So your recovery time is basically the time it takes to boot up the VM. Right. So even if you could have a 10 terabyte VM, but you're booting it up and it's ready to go. So you don't have to copy it out to primary storage.
Will it then stream the copy out to primary storage in the background while I'm running, or?
So then you can use storage vMotion to, since this is just another data store, you can use storage vMotion to move it out to whatever.
The system is designed for you to run your workload for some time. It's not that you power it on and run away.
Yeah.
You power it on, keep running it, go fix your primary, and everything is all right. Few weeks, few days, few hours later, whenever you are ready, storage will motion back, because as far as we are concerned, to your vCenter, we are another NFS data store, and just bring your data back.
And we also have a distributed metadata service that actually acts as the repository of all the metadata for the entire system. Again, this is distributed, it doesn't have a single point of failure. We actually have the metadata service running completely off flash, so this gives you very high, very short response times for any queries. And the interesting thing is we support offsite replication of the data, whether it's archiving or replication. So when you replicate the data, we also replicate the metadata. So even if you were to have a disaster and you actually lose your whole data center, you have the ability to rehydrate the metadata. And even, so for example, if you lose your Rubrik appliance because of a disaster, you can bring a new appliance, connect it to your archive, and all the metadata will come back. And so you don't lose any of this information.
So you mentioned disaster recovery. Is this something you can put in a DR site and have some form of failover?
Yes. I'll talk about replication shortly. And then we also built our own distributed task scheduler, which actually lets us, so each node, since each node this is a global scheduler that acts in a distributed fashion, it is able to marshal the resources across the cluster and schedule it based on what resource. So for example, if you have a very large VM, we can actually use all the resources in the cluster to stream it in parallel to reduce your ingest times as short as possible. And we use the flash resources across the cluster to be able to ingest that very quickly. If you have a lot of VMs, we can actually ingest them all in parallel, just reducing the amount of time is needed to ingest all the data into the system.
This is a very important point, because we are combining the functionality of backup software, which is catalog management, version management, and data acquisition, plus storage. So to be able to use a distributed system, to be able to acquire data and compress and deduplicate data and spread it over the cluster is a significant effort, just more than just building the storage platform. So we took the pain to really build a data acquisition and data orchestration engine that allows us to efficiently extract data without impacting the primary performance, and then immediately power it on in case you have any failure.
What do you think the ingest performance is of a single node, or not a single node, I guess a 4-node cluster?
Mm-hmm. It is 1.2 gig per second.
1.2 gig per second.
Per brick. So if you add
2U box with 4 nodes in it is 1.2 gig per second.
And if you add more, you can just scale that out as you need.
In fact, as an anecdote, about 18 months ago, when we first put our system in a friendly customer environment, our system was so much faster that it actually went after primary and took a lot of resources from primary. So we also built some intelligence around how to back off if the primary is busy or there is not enough network capacity or I/O bandwidth. So there's a lot of data acquisition intelligence that has been built into the platform, so that when you push our system in a busy enterprise class production environment, it seamlessly takes backup.
So the task scheduler is intelligent in the sense that not only looks at resources for Rubrik, it also looks at vSphere resources. So for example, if you have 100 VMs or 10 VMs on a single host, we don't go and back up all of them in one shot, because then that would have impact on the host. So again, we distribute it so that we make sure that we have minimal impact on production. So this takes all of that into account and schedules these, the backup operations according to those resources.
And the dedupe is done in parallel, offline, or inline? Offline.
No, it's done inline. And
done inline.
So we ingest into flash, and by the time you hit the hard disks, it's all dedupe data at that point. So we essentially stream it through flash.
And you mentioned it's globally deduped across the cluster?
Yes, because again, since the metadata is global, so any node can access the global metadata, we are able to dedupe across all the backups that have ingested.
And it's on a VM basis or a block basis, or is it variable dedupe, or?
So so the way we do dedupe is, again, we don't treat the VMs as black boxes. So we are able to, and since we also do search, for example, we are actually able to peer into the VMDK and kind of figure out what kind of VM it is. So we are able to actually detect VMs that are similar, and we have some IP around that. And so we match those VMs and dedupe across those. So for example, if you have 100 Windows VMs, the max dedupe you'll get is actually by deduping all the Windows OS, the common data. and then the per VM data may not dedupe as well. So we are able to do that. Secondly, we also leverage VMware change block tracking to only ingest the change data. We don't ingest the full data and try to dedupe within the system. So overall, so this is, so we are able to achieve kind of the best of both worlds in terms of deduplication.
So back to what you were saying, how it calculates everything it needs to do to intelligently devise this solution. But you just said a second ago that it also takes into account the number of VMs on one host, so it doesn't impact. Say all my critical VMs that have the highest level of protection all reside on that one host. Will it intelligently demotion to another host, or does it take that into account?
So it'll schedule the job so that it doesn't impact production. So it won't try to schedule 10 backup operations immediately concurrently on the same host, but it will stagger them to achieve.
But we can
bad architecture. You
Well, I know,
all
I'm
your
just
critical
thinking-
VMs on one host. but-
Yeah, I mean, I'm just thinking out of, that,
Yeah.
who knows what happened, but those 10 VMs,
Our goal is to do no harm. So we
Right.
don't take any direct action on your primary platform.
Okay.
If we detect that because of 10 most critical virtual machine running on a single host, and we are backing off because we don't want to go and take backup at the same time, and we are actually not meeting the SLA policy that you have asked us to do, we'll start to show you alerts, and you can read the alert, and then you can distribute your critical VMs.
so I can manually, but
Yes.
do you
Right.
make recommendations?
Yeah, we don't.
Yeah, we have recommendation.
Okay.
We'll give you that we are breaking the SLA.
But you won't actually take.
Okay.
No.
It's safer.
I mean, we don't want to impact production in
Okay.
any way.
Right.
We want to give you all the tools for you to make the right decisions.
But I mean, obviously, the chances of that happening are pretty slim. But
Yeah. So in our reporting, actually, you'll be able to see that we scheduled a backup for this time, but then we backed off and we actually waited until this time because of contention of this kind. So you'll be able to drill down and figure that out and then take the corrective action.
So nobody's asked yet. Sorry, I don't think anybody's asked. How large can it scale, and when does it become non-viable to be able to
So this
be
is
used globally?
So this is designed to scale, as much as you want. I mean, internally in our labs, we have tested up more than 50 nodes, scaling up to more than 50 nodes internally.
Do you have any real-world deployments that are a similar size?
So we have one real-world deployment that I think the biggest one we have is about 20 plus nodes.
So the thing is that system by design, as Nitro said, is designed for scale. But as a startup, we don't have resources to really set up like 200 node cluster. So we are actually, with every release, we are testing bigger and bigger cluster. In our lab, we have tested like 40 plus node cluster and even like boot it up and run at that scale.
What happens when you add a new node and you have to rebalance everything?
Sorry, can you say that again?
What happens when you have to add a new node and you have to rebalance everything?
The file system actually, once you add a new node, the file system will in the background start rebalancing the data. But that's a low impact activity. So we obviously prioritize backups. So that's number one. Or if you have taken any recovery actions, those get higher priority than all these actions. But it's kind of a slow, resync in the background. So for example, we might move new data to it as well as move some of the old data onto the new node. And over time, you'll see that the data is distributed across all the nodes.
Can you also decommission a node if you want to?
Yes, you can decommission a node. If you go through the dashboard and say I want to decommission this node, then again the file system will start creating new replicas for what is in that node in the remaining nodes, and over time it'll be ready to be removed.
Okay.
So you keep talking about quantity of nodes, but how much information or data does that actually scale to?
Again, this is we don't have. I mean, it's not designed to scale to as much data as you have.
So
we don't have any
per
limits.
box is so our most dense box for a 2U box with 4 nodes in it is 30 terabyte before deduplication and compression, and then you go from there.
Yeah, and most of our boxes that I've worked with in the field I've never seen really anything lower than 75% data efficiency. The systems I'm working with are typically in the upper 80% efficiency, so almost a 9-to-1, or 90% more space than what you started with. So 30 terabytes that you get kind of logically extend pretty extensively from the effective capacity. But obviously, it depends on if you're backing up cat videos or 900 the same Word doc, you know.
Okay.
And finally, I just want to cover search. So one of the key features that we have is the ability to search and recover just one file. So for example, if you have a large VM and you just want to recover one file, you can just do a predictive search. We actually index, all the snapshots are indexed, and we build this index and keep it on flash. And irrespective of whether the data is local, on the cloud, or on your archive storage, we can extract just that one file that you want. And that is actually, especially when you push to the cloud, you don't have to download a 10 terabyte VM to recover the 30K file. We can just recover the 130K file for you. And this is actually this is 90% of recovery operations are typically file recovery operations. And this is actually something that customers it really resonates with customers.
So this is like a truly global search. It searches across all versions of the VMs plus the cloud. So our cloud is fully indexed. And as you know, pushing data to Amazon is free. Keeping data on Amazon is also relatively cheap. Pulling data back from Amazon is expensive. In our case, since the Amazon or NFS or object store, whatever is your archiving destination of choice, we keep it fully indexed, deduplicated, compressed, encrypted, and indexed. You can pull one file without bringing the whole cloud back. And that changes the economics of cloud usage.
So, and you're probably going to go here because I think a comment was brought up about if it's just VMs, but does this cover Hyper-V, KVM?
Not today.
Not today.
But maybe.
It's in the roadmap, but it's not something you're supposed. We are focused on VMware today.
Okay.
The design is such that there's no reason we can't. Just got to build the adapter, basically.
Again, based on the software architecture I showed, basically you just add another connector and we should be able to support that. And finally, we support archiving. Again, this defines the policy, how much you want to retain in the archive, what you want to keep locally versus the archive. And we support both public cloud as well as object stores, private object stores like CleverSafe, Scality, as well as NFS for archive. So you can point us to any such storage like that, and we can archive to that, and still be able to. Rubrik will allow you to recover whether files or whole VMs from these archives.